Hey there, so today we're going to test and remove BIOS passwords from a couple of mainboards. So it's probably easier if we just go take a look, shall we?
Here's the boards here. They're a mini ITX Skylake board, and I've been tasked to clean and test. And also, if we come across any that are BIOS locked with a password, we're going to remove the password. Because unfortunately these boards, as many laptops and other PCs and laptops have, you can't clear the password just by removing the battery or setting the jumper. So what we have to do, if they are locked out, is image the BIOS, which is there, work out where the password is, remove it, and then flash it back to the chip, and hopefully that'll remove the password. As you can see, we've got quite a few to go through. There's one in each of these boxes, and they're all in an unknown condition. I've been told they may have worn fans. This one's not too bad, but it's got Ethernet port problem, so we'll look at this last. Yeah, so let's get to it. Okay, so we're just going to check this board out. There's a bit of dust and debris on that fan. Yeah, a little bit of dust and dirt on there. Alright, so the first thing we're going to do is get the electronic air duster and just give that a dust. Okay, so it's had a light dusting, so now we're just going to take the heatsink cooler off and give it a clean and some new thermal paste. That's actually alright. Alright, put some thermal paste on there. This is just GD900. It's not the best, but so bear in mind these processors are like 35 watts. Say i5 6500 Ti or 7400 Ti, so it's like the low powered processor. Alright, so that's re-thermal pasted. Now we're going to see if it has a BIOS password. I'm going to do that. So by quickly plugging it in, powering it on. Power him off. So these boards are pretty interesting. They run on 24 volt. Yeah, no ATX, and they actually power through these headers here. The board splits out 5 and 12 volts to drives and anything that you plug into it. Alright, so we'll move it over here. Alright, sorry guys, audio actually dropped out at this point, so I'm just doing this as a voiceover later on. So first up, we're just connecting the chip clamp very carefully. They're a little bit fiddly, those things, if you've ever used one. So we open the burner software.
And first thing we do is change the maximum current to 350 milliamps and also the clock frequency down to 8 megahertz. Because the difference between this and the cheaper burners that you get is it can supply a lot more current to the chip. Whilst the chip doesn't use that current, there's other components on the board that I theorize do draw some current away. So if you know what I'm talking about, the cheap in-system burners that you get on eBay for like 35 bucks, they just don't work. But this does work, and the main difference is the amount of current that the programmer can supply. So we set those two things up. Make sure the chip type is correct. In this case is the MX25L12873F, which is an MXIC branded chip, 128 meg. The image is only 16 megabytes that'll come off these chips though. So the first 8 megabytes is the BIOS software. The second 8 megabytes contains the Intel management engine and also any variables that are saved that we don't want cleared when we clear the real-time clock battery. So yeah, just accidentally saved that to the wrong location watching that. So yeah, it's an XGeku T48 that I use, and they're not cheap. They're about $150 to $170. You can get there's ones that came after this. They cost even more. But I find this one's pretty good. It covers like a few thousand chips, which is one thing I really liked about it. So anyways, opening that's the binary file there. We're going to open that in Notepad++ using the hex editor plugin. Not really important what editor you use, just as long as it works. So I've already previously found the location of the password in the second half of this file. They're a little bit sneaky because they put a space, so you've got like System Supervisor PW is where the password is saved. And they put a space in between each letter, so you can't easily look for keywords. So we're just looking at, I've already saved it, that hex value 500077 is capital P space lowercase w in ASCII. So just to make it easier to find in the future. So it's funny, some of these have them in two locations, some in one. That's system user password, which is for the BIOS boot menu. But I found that if you clear the system supervisor password menu, password variable here as shown, then it also resets the boot password, which is nice. So you don't have to clear both of them. Something interesting too, just up there, it's got System Supervisor Salt. That seems to be the value that the password is hashed against. Because if you save the same password on two boards, the variable there that you see is it's different, even though it's the same password. So all we do is clear the area between the 6 zeros and AA55. I keep moving it around. Where is it? Yeah, AA553C is the end, so that's like an indicator saying the end of the variable. The way I work that out is all the other variables have exactly the same 3 characters after the variable. So all we got to do is zero all those out. And by doing that, this board requires you to have a password. So it'll complain there's no password. You can then enter the password and the corresponding CRC32 value that it asks to confirm it with. So here I'm just saving the serial number, which I've also found in there. It's hex 4D5331. And I save it onto the file number because these boards need the specific BIOS image. Well, not so much the specific BIOS image, but they need to have that serial number entered into the variable because there's some software that will check the hard-coded serial number against the BIOS serial number. And if they mismatch, the software will say, oh, the BIOS has been tampered with. So yeah, just save that to the file name. I just save them all in case I need them in the future. Just makes it easier. Just look up the serial number of the board and drop the image on. Now we're just writing that image back to the chip, making sure that clock frequency is 4 or 8. Usually I put it on 4, but 8 I found to be reliable. Having it at 30, I've found the occasional read error. So yeah, succeeded. It's pretty straightforward. It's a good burner too. Like if any of the pins aren't connected properly, It'll let you know if the wrong chip is selected, as I did before I shot this video. So anyway, now time to plug everything in and see if it works. Okay, so now what we're looking for is to complain there's no password, so that we can then enter the supervisor password followed by the CRC32 hash of that password. It's not asking for the same password twice, and also with the F8 BIOS boot menu, it's doing the same thing there. Also got to enter the date and time. It's got you can see that. Admin password and BBS password should not be empty. So that's exactly what we're looking for. So now we can type in password, which I'm not going to say out loud. And we type in the... If you ever got one of these boards, you don't actually type in the password a second time. You type in the CRC32 verification value. So what you do is you search it online. There's like a website you can go to. You just want to get the CRC32 value of the password that you've entered. If you want more information, just ask down below and I'll explain it better. Alright, so there we go, rebooting now. Okay, so we're going to go into the BIOS. There we go, and we're going to set the date and time. And I just got to put the phone down for a second because I need to get the time and date off my phone. So I'll be right back. Okay, so date and time is entered. Now it's going to change it from UEFI to legacy so that it can boot off a USB drive, so we can do a BIOS update and run some diagnostics. Change it around, exit, save, yes. So while that's flashing, interestingly too, these boards, or heat sinks, unless the processor is at 100% all the time, it barely gets warm. So we're just going to go blow the dust out of the fan while we wait. Okay, so that's finished. BIOS 1.8 is now on there. So now we can boot up and run some diagnostics. Okay, so first up we're going to run a program called QuickTec Pro. This is just running the automation script, so it's going to go through and check all the mainboard components as is listed there. I'll actually stop it before it does a hard drive test because it tests the USB drive, so we don't want to do that, nor the memory test down the bottom because we use MEMTEST for an extended period for that one. So we're just going to wait for this to do its thing. Oh, another thing is we need to test this. The customer actually wants serial ports tested. So this lovely contraption is a serial loopback with our 3 LEDs and the loopback connections. So yeah, once these mainboard tests complete, we'll do a serial port 2 loopback test. Okay, so that's pretty much finished now. Now it's doing the hard drive test, which we don't want it to do, so we're going to abort out of that. Pass. And now we're going to go and do COM2. We'll also do the, it's pretty good, this program, you do USB ports and everything. Considering it's a very small program. So it's got external loopback, so one of these doesn't actually work, which is the external loopback status down the bottom. And apparently you have to use their proprietary loopback tester for that test to work, but it does everything else. So I mean, if it's going to have a failure, it's going to fail somewhere else as well. So yeah, that one will fail. Then that works, so that's the actual loopback. As you can see, the I missed it. The red lights flash when it runs that test, so you can see that it's receiving and transmitting data fine.
So I'll just let this go for a couple minutes and then we'll move on to the next test. Okay, so that's been running for quite a few minutes now. Just thinking before, to be honest, I can't actually remember the last time I came across a faulty COM port. And you're probably thinking, who on earth uses COM ports anymore? Well, these boards are, I won't call them industrial, but I'll call them commercial PC cores or mainboards. So they run your commercial applications like your ATMs and self-serve checkouts and what else? Yeah, checkouts, that kind of stuff. So yeah, if you're wondering, shouldn't be running that without a fan. If I can hold my hand on that, it's not that hot. So this is probably about 30, 35 degrees, I'd guess. And it's a pretty cold day today, so yeah, I could plug the fan on and I probably will in a minute. So anyway, let's move on to the next test. If you're wondering, that looks pretty dodgy compared to a normal serial loopback tester. And you're probably thinking, Mike, why don't you just plug a header in there? You've probably got a heap laying around. Well, you're absolutely right, I do have a heap laying around, but the pinouts are completely different on these boards to what a normal PC has. So there's my normal loopback I'd use and header, but yeah, because the manufacturer decided to do the pinouts different, I had to make this contraption. Okay, we're going to start MEMTEST. Now that's actually MEMTEST 7.2, I just didn't update the menu properly, as you can see. So we're going to let MEMTEST run an iteration, about 25 or so minutes, and see how it goes. So these boards I've only quoted because this is actually some paid work I'm doing, and I've got 600 boards to do. I'm quoting 45 minutes per board, so I pretty much got to keep my time. What I would do if this was my own board, or if it was for us, if I was fixing someone's home computer, where I'd tend to spend a little bit more time. It's kind of different. So yeah, 45 minutes a board, 20-25 minutes of testing. Yeah, otherwise we're not going to get through several hundred of these boards anytime soon. So yeah, once this finishes, we'll come back and move on to the next test. So yeah, you'll probably notice that the power supply fan's ramped up while running MEMTEST. Up there. So I've actually put the fan back on, so it's starting to get a little bit warm. Right, so that's been going for 27 minutes now, as we can see, and it has passed. So I'm happy with that. Now we are going to boot up a Linux called Slacks Linux that can be booted from USB. So we're going to boot into that and check the Ethernet connection. First up, just checking we have connectivity. So green on the left, orange on the right, which is good. Now we're in Linux, which is like this one's like a copy of Windows 10. So all I do is just open up the browser and make sure that I can browse the web. Because if we can do that, that's fine. So the trick with this is I've been literally given 45 minutes to do as much testing as I possibly can. So I pretty much concluded that if I can browse the web reliably, then she's all good, which we appear to be able to do. Usually it just comes straight up with a little dinosaur game if it's not connected. So yeah, just click around in the Microsoft website, make sure it's worked, which it is, and we're all good. So now we can finish up. Now all we've got to do is pretty much remove the memory, just give it another check over for dust and whatever, and that's it. That's our 45 minutes done and board tested and BIOS removed. Oh, BIOS password, sorry. So I thought I'd finish up with just a quick tour of the board. So these boards have got 2 Ethernet. Most of the time it only has 1, so you can actually see the chip isn't physically present for the top Ethernet port. So it's just a 10, 100, 1000, so gigabit connection. 2 display port, 6 USB 3, even though they got the black tongue, those are all USB 3. Typical audio and digital microphone. The board runs on 24 volts through this connector, and I believe, even though it generally only has 2 wires, you can actually put 4 in there like that. There's 2 power, 2 earth on the connector, but for whatever reason I only have those 2. Probably because, I mean, you saw on the power supply it only draws about 1.7 amps on 24 volts, so the thickness of those wires is more than enough, and I've never felt them ever get warm in the slightest. It's got 2 COM ports where you can change the voltage between 3.3, 5 and 12 volt. CMOS battery. There is that's a Clear CMOS jumper. 2 USB 2 headers. System fan. This connector on the edge here has like a expansion board that attaches to the side. That gives you an extra PCI Express slot and a normal PCI slot. That's a PCI Express 4 slot as well. What else we got? BIOS is there. Just get a little pointer, hang on. So yeah, SPI BIOS chip there, and that's the programming header, which basically just matches with those pinouts. So using the clip or that's fine. That's the TPM 2.0 header. It's got 3 SATA ports. Not sure what that is. It says SATA P3. I don't know what that is. These 3 are power out, so you got 5 volt, ground, and 12 volt on each 3 of these. Usually there's a header here. That is for the diagnostic board, which I've never actually seen. I don't even know if it exists. Some of the boards do actually have that header on there. This is for what's called a Purit board, so that provides remote power on off for like depending what it's plugged into. The system can turn it on and off, reset it. Also has a power button, hard drive, and power LED. We've got PS2 mouse header, digital display output via ribbon cable if it's got like a touch screen, LCD touchscreen, and yeah, that's pretty much it. I mean, yeah, fan header for the CPU fan. So yeah, that's pretty much it. So not a bad little board actually. I wouldn't mind using these as like a media center kind of thing. Currently using this thing, which is incredibly underpowered as my media server. But it does alright. It's got like a dual core Celeron 6-watt processor, which is, yeah, I've just been tinkering with it, which is why it's on my workbench. Eventually I'll put it somewhere else. But anyway, enough drivel. So yeah, that is the Skylake Misano mainboards that I've been working on. So yeah, got a couple hundred more of these to go. And yeah, so that's what I've been working on pretty much. I can't wait to actually finish these and actually do some more interesting stuff. I've still got my Pentium 4 sitting here that's waiting for me to do a few more things on it, if you've seen the previous videos. And I've also been thinking of getting the old 486 down and rebuilding that and actually doing some proper old hardware. But I mean, this is paid work, so paid work takes priority over fun, unfortunately. So yeah, that's what I've been up to. So any questions you can leave it down below as usual. But apart from that, I'll catch you next video. And hopefully next video we'll be having a bit more fun. Catch you later.